Welcome back, students, to our geometry class, chapter Similarity, practice set 1.3, part 2.
So let's continue with our practice set 1.3. In our last video, we solved sums up to sum number 5. Now we will start with sum number 6 from practice set 1.3. We'll read the sum. In trapezium ABCD, in the given figure here 1.60, side AB parallel to side DC. Diagonals AC and BD intersect in point O. Given if AB is 20, DC is 6 and OB is 15, then find OD. Okay. When we look at the figure from the given information, this is a trapezium ABCD. Okay, and from here AB is parallel to DC, whereas these two AC and BD are the diagonals which intersect at O. Okay, they have given AB is 20, so we just mention here AB as 20, no units are given, DC as 6, OB as 15, and we have to find OD. Now if you look at this, what is given and what is asked to find, from here you will see that these are the sides of these two triangles. If you look at triangle COD and triangle AOB, whatever given lengths are given are the lengths of the sides of these two triangles, and they have asked us to find OD. How will we solve this now? Now, if they are the sides of the triangles, if we prove that the sides are in proportion, we can find the side OD. When we can write the sides are in proportion? Only when the triangles are similar. So we will see how we can prove these two triangles, COD triangle and triangle AOB, are similar. Okay, so we have to prove them similar by some test. So by which test? Now they have given sides, but they have given sides of this triangle AOB, only these two sides we know, and here only one side. So we cannot go for SSS test or we cannot go for SAS test. So the left test is only AA test. So let's try for AA test. Now in AA test, if you look at triangle COD and triangle AOB, these two angles here, angle COD and angle AOB, we can write they are congruent by vertically opposite angles. Okay. Now we need one more angle. So from the given information here, since it is a trapezium and AB is parallel to CD, and if one of the diagonal acts as a transversal, we can get the alternate angles are congruent, with which we will get another angle of a triangle. So let's begin. Okay, so before we start proving that the triangles are similar, we will first prove the alternate angles are congruent. So, solution, we will write, since AB is parallel to DC, which is given. Okay, and if I take BD as a transversal, you can also take CA as a transversal. Accordingly, the alternate angles will change. So if I take BD is a transversal, if AB is parallel to CD and if BD is a transversal, where is the alternate angle here? So you can see these two angles, they become the alternate angles. Okay, so therefore we can write angle CDB is congruent to angle ABD. The reason is alternate angle theorem. You have done this in standard 9th. Now if you look at this CDB, we don't want CDB. Since we are taking these two small triangles, we want only CDO. CDB and CDO is one and the same. So it is the same angles having different names. So instead of this CDB, I can write CDO. Similar way, ABD, I can write ABO. Angle ABO. You can write two reasons here. Any one reason you can write from this two. You can write same angles having different names, or you can write B dash O dash D. Since B dash O dash D, you can name it as CDO or CDB. Okay. So this also you have studied in 9th standard, betweenness. Let us give this as statement 1. Now, we come to triangle. Therefore, in triangle, CDO and triangle ABO. In these two triangles, angle CDO congruent to angle ABO from 1. Just now what we proved. And second, I can write angles COD congruent to angle AOB. Now look at angle COD and AOB. They are vertically opposite angles. These two angles. Okay. COD and AOB. Since they are vertically opposite angles, you'll write reason here. Vertically opposite angles. Therefore, we can write triangle CDO similar to triangle ABO by a test of similarity. Okay, by a test of similarity. Once you prove by a test of similarity, we can write the sides are in proportion. Now, therefore, CD upon AB, you can write from this names. If you have written according to 1-to-1 correspondence, directly from here you can write the proportional sides. You don't need to look in the figure. So, CD upon AB, DO upon BO, DO upon BO and CO upon AO. Corresponding sides of similar triangle. Okay. Now, in the given information they have given the lengths of some sides. So, we will substitute that. So, CD which is DC is given. So, CD and DC is one and the same is 6. AB is given 20. DO is asked to find. OD is asked to find. So, it is one and the same. OB is 15. CO and AO, nothing is given. So, that is fine. Okay. Now, if you look at this, we will take the first and the second ratio. Third, nothing is given, so we need not take that. We will take the first and the second. In this, out of the 4 things, 3 things we know. So, we can find the fourth. So, we take 6 upon 20, which is equal to DO upon 15. We just cross multiply. So, 6 into 15 is equal to DO into 20. That gives us 6 into 15 upon 20. Okay. Now, we just simple calculation. So, 5 3s are 5 4s are 2 2s are 2 3s are. So, we have got DO which is equal to 9 upon 2. Now, we will not keep this as a fraction. We will convert this. So DO is 4.5. No units, so you can write units. They have asked us OD. Okay, so OD and DO is one of the same, but at the end you will make this as OD is equal to 4.5 units, and you will underline your answer. Okay, you can take a pen and a scale and underline the answer or make a box. I hope this sum is clear with you all. Okay, we proceed to the next sum. That is sum number 7. Now, look at this sum. In this sum, they have given a figure. Okay, and the given information says that quadrilateral ABCD is a parallelogram. So this ABCD is a parallelogram. Point E is on side BC. So E is on BC, we can see. Then line DE is intersecting the ray AB at T. So this DE is extended so that it meets this AB at T. Okay, we have to prove that DE into BE is equal to CE into TE. Again, if you look at the given information, the figure and what is asked to find, you will see here that what is asked to find, it has this two sides which are multiplied. On the other side also two sides are multiplied. If you cross multiply or if you just exchange, okay, you will get the proportional sides. Okay, if I bring one side here, it will become divided, that is, it will show proportion. So from here also you have to decide that it is something about proving the triangle similar. After that, showing the sides are in proportion, and then when you cross multiply you will get this. Okay, so any sum you first read, you first see what is given and what is asked to find. Also look at the figure, and then you decide that what will be your step in order that you come to the conclusion or what is asked. Okay, so looking at all this information, we know that we want this something which is with multiplied, the sides are multiplied on both the sides. If we exchange, we will get proportion. So we will prove some triangles similar. Now which triangles? It is DE and BE. So look at DE, BE, CE and TE, CE and TE. So you will see here, if we take this particular triangle here and this particular triangle. So what are the names of these triangles? We can name it as BET and CED. So if we prove these particular two triangles similar, we can write the sides are in proportion, and when we cross multiply, we may get this. Okay, so we begin. Now to prove the sides are triangles are similar. So again, by which test? We don't know anything about the sides. So look at the angles. Yes, there are vertically opposite angles, but what about the other angle? One more thing, one information given here is parallelogram. Okay, this parallelogram tells us that we can get one angle here. Now we have studied the properties of parallelogram. Now what is one of the property of parallelogram? That the opposite sides are parallel. Okay, now if opposite sides are parallel, we can get some angle, maybe alternate angle corresponding, we will see what. Now if you look here, ABCD is a parallelogram. So here AB is parallel to CD. Okay, if AB is parallel to CD and this point T is in a straight line with AB, because in the given it is said that when AB is extended, it meets this ray here at T. So that proves that A dash, B dash, T, they are in one line. So if AB is parallel to DC, AT is also parallel to DC. Okay, and we can take DT as a transversal, and we can prove that the alternate angles are congruent. We'll see how. We begin. Okay. Now, given is quadrilateral ABCD is a parallelogram. Okay. Therefore, AB parallel to DC. Okay. It is a property of parallelogram. Now, since DE intersects ray AB in point T, we can write that A dash, B dash, T. Okay. Therefore, when DT is a transversal, we assume that DT is a transversal. Therefore, if, look at the figure, if AB is parallel to DT, then AT is also parallel to DC. And if this DT is a transversal, we can get these two as alternate angles. Okay, so we write here, since A dash, B dash, T, if AB is parallel to DC, we can write AT is also parallel to DC. Okay, and if DT is a transversal, I can write that is angle ATD is congruent, angle, look here, ATD is congruent to CDT. CDT. Reason, alternate angle theorem. Okay. Now if you look at the figure, we were talking about these two triangles. Okay. Therefore, we want BTE. We don't want ATD. So instead of ATD, I can write BTE. Okay. Angle BTE. And instead of CDT, look at here, look in the figure, CDT, I can write CDE, because we are talking only about these two triangles. So we don't want that big angle. We want angle only which is there in that triangle. So instead of CDT, I will write CDE. Same angles with different names. Or you can write A dash, B dash, T, and here you can write D dash, E dash, T. Any one reason you can write. Okay. Now, this we can give as statement 1. Now we go to this triangle. This one alternate angle we have got, and other will be the vertically opposite angle. Okay. Therefore, we can prove the triangles are similar. So, before that we have to take the triangles here. So, in triangle, okay, BET and triangle CET. Okay, write the names of the triangle properly. In triangle BET and CED. Okay, what happens here? We know that vertically opposite angles. So, angle BET congruent to angle CED. Okay, BET congruent to CED, reason vertically opposite angles. And the other angle what we proved as alternate, that is angle BTE congruent to CDE from 1. Therefore, triangle BET similar to triangle CED by AA test of similarity. Okay. Now, since we know after we prove the triangles are similar, the sides are in proportion. Now, which sides we want here? DE, DE, CE and TE. Only those sides we will take in proportion. If you want, we can write all the three and then select the two. Even that is okay. So, we will do that only. BE upon CE. So, there is no confusion. ET upon ED. And last is BT upon CD. Corresponding sides of similar triangle. So, I have taken all the three sides. BE upon CE, ET upon ED and BT upon CD. Now, from this, which we want, we will select. Only those two ratios we will take. We want DE. We want TE. ET and TE is one and the same. So, we will take this. Then we want BE and we want C. So, first two only we will take. We don't want BT and CD. So, we will not take this. So, we will take BE upon CE, which is equal to ET upon ED. Okay, just from the above, we have taken only the two ratios which we want. Now, we cross multiply. So, BE multiplied by ED is equal to ET multiplied by CE. We just cross multiplied. Now, here it is ED, but we are as DE. So, we will just make it. We will just make it as BE, let it be as BE only. But ED we will write as DE. Okay, ED and DE is one and the same. Just writing the other way. And then, yes, CE into TE I will write because they have asked TE. Okay, so ET and TE is one and the same. So, just making it as they have asked here. Okay, we just want it, see that your final answer looks like this. And to look like that, I have to just make little corrections. That is, BE into, instead of ED, I wrote DE equal to, first they have asked CE. So, I wrote CE into, instead of ET, I have written is proved. I hope this is clear. Okay, now we will go to the next. That is the 8th sum. Look at the 8th sum. It's quite simple. The figure is given. Here AC and BD intersects at P, which is also shown in the figure. Given is AP upon CP is equal to BP upon PD. Okay, and we have to prove these two triangles are similar. Now, two sides are shown in proportion. Now, to show the triangle similar, in one of the tests of similarity, it is SAS test, where there are two sides which are proportional and between those two sides there is an angle. Now, which two sides are given here? AP upon CP and BP upon DP. Between these two sides, this angle is there. Are these angles congruent? Yes, they are vertically opposite angles. So, they are congruent. So, if between two sides which are in proportion, there is an angle which are also congruent, then we can prove that the triangles are similar by SAS test of similarity. So, this is very simple sum. So, we start. Okay. We take the names of the triangles A, B, P and triangle. So, it is A, B, P. Okay. And what will be the other name? Because AP upon CP is given. So, opposite. So, A BP. So CDP. So before you start with the sum, just check whether they have given according to one-to-one correspondence. If they have not given, usually they give according to one-to-one correspondence, but if it is not given, then you make sure that you write according to one-to-one correspondence. Now, here we know AP upon CP is equal to BP upon DP, which is given. Then we write angle APB is congruent to angle CPD. APB congruent to CPD. This vertically opposite angles I wrote. So the reason comes here, vertically opposite angles. Try to write the reason in a bracket. Therefore, triangle ABP similar to triangle CDP by SAS test of similarity. Okay, I hope you have understood. This was a very simple and a short sum. And now we go to the last sum of this exercise, practice set 1.3, that is a ninth sum. Now, in this sum you will see the figures given, and it's triangle ABC where there is a point D on BC such that they have given the angles which are congruent, angle BAC congruent to ADC. We have to prove this again. Again, if you look at what is asked to prove, triangles are there already. But what is asked to prove, you will see the sides are there and on both the sides, and there is a multiplication sign. Again, the sum what we did earlier, that is, if you shift the sides, you will get the proportional sides. Okay, that means here also you have to prove some triangles similar, so that you can come to this conclusion. Now, which triangles you have to decide from this? CA square means 2 times CA, CA into CA. So where is CA? CA is here. CB, CB and CD. 2 times CA means in both the triangles CA, we'll see how it is, but in both the triangles you should get CA because CA is 2 times. So if you look at what is asked from here, we can conclude that we will take this big triangle first. Okay. And we will take this small triangle here, ADC. Okay. So, in triangle. Okay. How you will name it? This angle A, this big angle A is congruent to this D. So, be careful when you are naming. And there is something common. If you look at triangle ABC and triangle ADC, C is common. Okay. So, how you will name this? If I name this as BAC, the first triangle, BAC, this A is congruent to this D. So the other name will be triangle ADC. I'll show you why. Angle A, that is BAC, is congruent to angle D, ADC. So here I have written in center, so here also it has to come in center. C is at the end, which is common. So here also C has to come at the end. Okay. So the names of the triangles are written first according to one-to-one correspondence, that is BAC and ADC. Now from here we know that angle BAC is congruent to angle ADC. It is given here. BAC, this big angle here I will show you. So this big angle is congruent to this here. It is already given. Second, I told you there is something common, angle C. So how you will name it? Angle BCA is congruent to angle ACD. See, BCA of the bigger triangle and ACD of the smaller triangle. Here you will write reason as common angle. Therefore, triangle BAC is similar to triangle ADC by a test of similarity. Okay. Now, we know when the triangles are similar, sides are in proportion. So, we will write the sides which are in proportion. So, BA upon AD, BA upon AD is equal to CA upon CD. I am writing CA because what is asked, we want CA. So try to write, don't write AC, write CA. So it is easier for you to get the answer fast. So BA upon AD, BA upon AD, CA upon CD, and what is the last one? CB upon CA. CB upon CA. Okay, so all the possible three sides, first and second, then second and third, then the first and third. CSST, corresponding sides of similar triangle. Now, which two you will take here? Now, come back here. You want CA square. So, when you will get CA square? When you take the second and the third, CA into CA. So, you will take the second and the third only. Cross multiply. CA into CA, and here it is CB into CD. CA into CA is CA square, which is equal to CB into CD, which is asked to prove, is proved. Okay. You can just underline or make a box, or you can underline the answer. With this, we finished with our practice set 1.3.
Homework. Complete the sums from practice set 1.3 in your notebook. Stay home, stay safe. Thank you.